Okay, here we go with another video, picking up where we left off on comparison operators, I believe. I actually had this video already made, but it got interrupted a little bit, and I had to delete the video. It happens. Anyways, if I'm not mistaken, on previous videos, I'm going to do a little recap here. This is not the code that we had, but I think first I probably ought to readjust the view here a little bit. That way you guys can see what I'm talking about. There we go. I believe our last video was on comparison operators, but just in case I'm skipping something, I'm sure we'll probably come back to this again eventually, either one. So, just to recap, we've started in operators on this part. Operators being basically anything that links things together, in my opinion. Let's clear this up real quick. Not all of it. Clear that up. Get rid of all this. So, I'm going to go off this list right here as a recap. Operators kind of gives you, I think actually, you know what, let's go back and take a quick look at it real quick. So operators, it started with the plus operator. We kind of went into the assignment operator there a little bit with that one. Moving on to the next one, and we had the arithmetic operators. So the addition, subtraction, multiplication, division. I don't know where we left off on the last video because, like I said, I made this video already. But anyways, increment and decrement. I do know that I made a list in my last video that got deleted. So operators in total. So first off, we had the addition one, which is in this as well. These are all known as the arithmetic operators. And make a little bit of an adjustment here so we know. All right. And then I think it went into, yep, explaining that we had the increment and decrement operators, so we'll make that one as another one. Increment and decrement. And I think that was all of that one right there. I'm not sure if we did this exercise or not in a previous video, but like I said, I'm just kind of zooming over this, going back to the comparison operators. I'm pretty sure we did, but if not, we'll cover it again, so eventually. And we had the assignment operators, which we kind of went over this in another video, I believe. So we got, let me put a space right there because we are doing spaces there. Assignment. Operators. And then we got a list of them right here. This one right here, I'm going to add this in because it is part assignment and other things. And there's a huge list of it down here. So besides just the arithmetic, increment, decrement, and assignment operators, there's also something else known as a compound. Now, this exercise specifically mentions addition compound, but I'm just going to put it as its own category because it can be actually more than just addition or assignment. Actually, I'm going to go ahead and add the assignment in there because normally it is assignment of some sort. So, and then we got the list of them. I think I mentioned all this in a previous video, but I'm not sure. Probably should have gone back and looked at the last video and looked at the last 5 minutes of the last video to see where it really left off, but it's fine. Like I said, we'll probably eventually get back to this anyway, so. I'm looking for any other kind of operators besides the next one, comparison operators. So comparison operators would be the next one here. Oops. And if you watch these videos and stuff, feel free to watch the video at the same time if you are trying to learn the code to put the code into something. Some sort of editor, doesn't matter if it's the built-in editor because you haven't quite downloaded or decided on a different editor, or a downloaded editor you did decide on. But currently we have looked into these right here. We're getting ready to go into comparison operators. Just kind of a brief description of them. So arithmetic operators is pretty much what it says. Does arithmetic, whether it's adding, subtracting, multiplying, dividing, something that we're not familiar with, which is the remainder of, but it's also known as modulus. Then you got the increment and decrement operators, which actually causes whatever the value is of a variable to be increased or decreased. And then you got assignment operators, which is where we're actually assigning stuff. So here, instead of actually saying it, let's just go ahead and type them out. So we got the arithmetic, which includes, if we are doing values, int x is 5, int y is 6, int z. Here's where this arithmetic operator comes in play in one way. 5 plus 6, oops, 6, which is actually a new value. It's not the same as either one of those, but it can also be written as int x, sorry, let's go with A, running out of letters there, x plus y. Now currently none of these are identical to each other. They are, but they're not. So x is 5, y is 6. This is all the assignment stuff right here, going with this one right here. Z, we're combining two different operators right here, assignment and arithmetic together. So we got the assignment Z is 5 plus 6, the arithmetic being the plus. But it doesn't have to be just values like you see right here. It can be variables too. I think in another video and stuff I showed how you can do that with other types. So it doesn't have to just be integer types. So this is where we are starting to mix and match types, keywords, values, variables, using different assignments or different operators. Another one you see quite often. So how many different operators are in this when you are putting this together? Okay, so how many different operators are there? Well, let's see. The first operator we have is this one right here. We haven't discussed that one yet. That is another operator. We just haven't discussed it yet. This one right here. We have discussed this one right here. I also probably need to add that in down here. This is the insertion and extraction operator. Then we got the string right there. Another insertion operator right there. This is really not an operator as far as I know. This is more of something familiar with char. I can't remember what that's actually called, but we'll get to that again later and stuff. It's why we kind of go over this right here and then go over another one and go over another one and kind of cycle back through all of it at the same time again, so it kind of gets to be repetitive. I would say that this though right here is, oops, it wasn't supposed to happen like that. This one right here is another operator. because that ends the statement. We just haven't discussed what kind of operator that is yet. Um, and the reason we haven't is because most of our operators have something on both sides of them. This one does not. We haven't discussed this one either yet. But the assignment operator has something on both sides of it. We'll get into what these are called later on. If you're familiar with math and stuff, you probably recognize this as being the operator and then the operands, but we'll get into that later. So we got those. That's arithmetic, that's assignment, and insertion and extraction. The extraction one being the one that goes the opposite direction and stuff for the input. This is the output, the other one would be the input. And increment and decrement we've seen as being plus plus x or x plus plus. Sorry. Okay. So it covers three of them. We haven't gotten into compound yet or comparison, which is where we're at right now. So that's what we're going to start covering, both these other two that we haven't discussed yet. So let's go ahead and get rid of all this. We'll go ahead and keep that bottom section down, and we're familiar with all this stuff. So comparison operators. The reason why we're doing comparison first before we do compound, even though I think it mentions compound prior to this lesson, is because compound actually goes with a lot of different ones. Compound is a mixture of two different operators, not just one. But I'm putting in its own category because of it mixing operators. So comparison, and like I said, I am not teaching this stuff. This is kind of me just refreshing my mind on what I've learned so far, seeing what I can do with what I've learned so far, showing you the journey I've taken so far, sort of thing. So in the comments, if you want to adjust what I've said, saying, no, he's wrong about this, he's wrong about that, or he's correct about this, or adjust what I've said, he is right about this, but this goes with this too, that's perfectly fine. If you want to throw that in the comments, it's perfectly fine by me. Eventually we'll get through all of it anyways and stuff, so I mean, it's just not going to be in any specific order, especially when there's so much more information that's involved in anything. But taking and learning a little bit about everything is kind of how I did it. So I learned a little bit about everything, then I got a deeper dive into each category a little more, and then more and more, and then I went back and recycled and stuff and started back over again at the beginning and realized what the deepness was with everything that way. I mean, there's more than just a car than just going down the road on four wheels in a box. And in my opinion and stuff, that's the simplicity of a car. Four wheels on a box. So anyways, comparison operators are used to compare two values or variables. This is important in programming because it helps us to find answers and make decisions. The return value of a comparison is either 1 or 0, which means true for 1 or false for 0. These values are known as Boolean values, and you will learn more about them in Boolean chapters, according to this lesson right here. The following example, we use greater than operator. Okay, so this is the first we're hearing about comparison operators, and the first example we're running into for this. So let's go ahead and type out this example. Int x is 5, int y is 3. And then we have an output here, standard character out, extraction operator, sorry, insertion operator. Trying to remember those and stuff, and I may be getting them wrong, but trying to remember them the way they're supposed to be said is back and forth. Now, my question here is, this is the example, and there is a note behind this, but I'm not going to write the note just yet. So the output is x is greater than y. My first kind of thought to this is asking a question or is this telling us something? I don't really know. It depends on how you think of it. That's why these are considered comparisons, because it can be written so many different ways and be worded so many different ways to come up with an obvious conclusion. Okay, so let's go ahead and put the comment in here. Returns 1, which is what this should return, for true, because 5 is greater than 3. Still, we don't know if it's asking a question or giving a statement at this point in time. We just know that it's going to return 1, true, because I didn't even spell because right. 5 is greater than 3. Let's go ahead and save it right there and make sure that's what we're getting. And yes, we got 1. So, when it comes to comparison operators, we got a list of them here. Let's go ahead and clear this out. We're going to go ahead and clear this out too and stuff. Writing that down multiple times and stuff will help you to remember them. And the different operators. Believe me, there's a crap ton of keywords too. So when it comes to C++, there's a huge list of a lot of different things you can throw into a code to get it to work for a program you want it to work. So instead of actually just naming these off, because I think the video I did prior to this one when I deleted it and stuff kind of named a few of these off. Instead of doing that, I want to refer you again to this right here. Assignment operators right there. Okay. And it does include compound operators. So let me zoom in here real quick on this so you can see it better. So the first thing you have is the assignment operator, and then you have an addition assignment operator. So that's a compound operator. You got two different operators in one. Subtraction assignment. So it's the same thing as the addition assignment, except for it has subtraction in it instead. Multiplication, you got division assignment, remainder assignment, and then you get into bitwise, and we haven't even discussed that yet. And we're not going to yet because we're not there yet, but just realize it's there. And assignment, or assignment, X or assignment, uh, shift left assignment, shift right assignment. Now, what about the rest of them? So we also got, go away, thank you, increment assignments. Okay, and we did kind of discuss what's the difference between having the plus plus x or x plus plus. So here's kind of where that is. So we got pre-increment, pre-decrement, post-increment, post-decrement. And I'm pretty sure it says right through here and stuff the difference between those and how they can kind of change things. Like for example right here, prefix operators. The prefix increment and decrement expressions have the form this with the expression. Prefix increment pre-increments, prefix decrement pre-decrements. What about the post? Does it say anything about the post? Yes, right there. The post increment and decrement express form is this right here, post, so forth and so on. And then it has even some more information on built-in prefix operators, so forth and so on. And then down here, built-in postfix. So there's quite a bit of information right there on that. Going back, go away. Arithmetic operators, we got a bunch here. We got the plus, no, sorry. We got the unary plus. So that we're kind of getting way out of the W3 school area that we're in right now. But unary plus, unary minus, addition, subtraction, multiplication, division, remainder. And then we get the bit again, so not and more. XOR, and I haven't even dealt with the bitwise stuff yet. So just knowing it's there is the key to this right now. Just knowing it's possible. What you can do with it, we're going to have to go pretty far into all this and stuff in order to understand how you can manipulate all this stuff. Just realize that it's there. That's the key behind it. Some notes on the stuff, some general explanation, conversations, overflows. Like I said, knowing it's there is currently the battle. And then you get the logic, which we haven't discussed about the logic operators yet, but logic operators not, and, or, and those are pretty much the only three for logic operators. Basically, X and Y, uh, not X, not Y, not equal sort of thing kind of stuff. And then you got the comparison operators, which is the one we're dealing with, which is equal to, not equal to, less than, greater to, less than or equal to, etc., etc. So, like I said, we haven't gotten into all this yet. This is a lot deeper than what we're currently working at. So let's go ahead and focus back on this right here. Just knowing that comparison operators exist is one thing. Using this example to kind of show or demonstrate how one of them works, just one works, with all the many of them that are out there. And then we got a couple real life examples here. The first one deals with whether you're old enough to vote or not. So you write a program stating whether you're old enough to vote. And age is 18, so that's our minimum age and stuff to be able to vote. So then we would output age greater than, oops, put a space in there, greater than, equal to 18, which is pretty much stating, are you older, or are you 18 or older, is pretty much what this is stating. And then we're going to finish the output with the insertion, and then break a new line for the next line. Now, I don't really like how they have this set up in here. This one ain't too bad, but there's no explanation to it. It's not really, it's just basically kind of showing you how the operator would work. It's not really kind of demonstrating how you would set up a program and stuff to determine an age. So don't put your focus so much on what the program is currently doing. Put your focus more on what the operator is, how the operator is being used. Actually, yeah, down, tab, space, another insertion, and the rest of the example here, age, space, nope, wrong one, there we go, 18, and then we'll end that right there. And then, yes, we have some comments here. I'm going to put the comments down here, though. So, one, again, something very important to remember. If it comes out as 1 when you have a comparison operation, which is basically something true or false, is true. 1 equals true all the time. In this case, old enough to vote, and 0, if I can get it in there, being false. Like I said, it's not so much about this part right here, determining whether somebody's old enough, which would be what the program would be designed for, because the program is not fully written out. It's more about the operators. Okay. In this case and stuff, if we were to pretend that 18 is an age of voting ability, when you reach 18, that means you can vote. So is age, which is this, 18 or greater? And in this case, it's equal to. So it's 18. The operator is determining that 18 is 18, or age is 18. And this one right here is 18, is aged less than. So you would actually have to write some text in there and stuff to get this to make sense as an output. Otherwise, right now and stuff, the only thing we're going to end up getting with this, I'm going to save that real quick and then run it so we can see it, is this right here. And we have no idea what this is. Not unless we were the one that actually specifically wrote the program and stuff, and we're using the program ourselves and stuff. But then even at that and stuff, if you don't consistently remember it and put it together, you're not going to. Give me just a second. I got a cat that wants out. All right, I am back. So, like I said, not a very good program right here, but this is not about the program. It's about the operators. Just getting used to the idea that greater than, equal to, how you can use them in a program. Can we write a program with this? Somewhat. It's not going to be a very complex program, but yes, we can probably write a program with this. I'm going to have to add some text and all that sort of stuff. Let's move on to the next part. How else can we use this for an example? Well, the next example goes into, in fact, I don't even think I read the first one, but yeah, the next example goes into password length. A lot of programs or a lot of things and stuff, when you create an account for a program, whether it be a Facebook account, a game account, whatever kind of account, they want a password. A lot of times those passwords and stuff have a minimum or maximum length to them. Okay. In the program and stuff, when it's determining a password and stuff behind the scenes, what you don't see could be the same as, oops, I wasn't supposed to get rid of that. There we go. Could be the same as this. So you got the integer password, and I'm just like still copying this from what we have here because I'm not making up any of my own stuff yet. I'm just showing the examples in a bigger form and getting the exercise myself. Standard output insertion, and then using password length to determine if the password length is long enough or not. Now, this is the one I really don't like for this kind of program, but like I said, we're not focused so much on the program itself as much as we are the use of the comparison operators. 8. So we want a bare minimum of 8 characters long. Or if it's less than 8 characters long. Trying to get my typing to work properly for me. So there's our little example. Password, in most cases and stuff, this is not even going to be an existing value for password because the program's not going to know how long your password's actually going to be until you input it. Normally you have a range of minimum characters and maximum characters. We are making up a range as if we were to put the password on ourselves, but we're only putting 5 characters in there and stuff, and we're stating that, and the program is set up to where it's a minimum of 8. There's no maximum currently. So it's got to be at least 8. At least. That's where the and comes in. The compound says it can be greater than. Oops. The compound says it can also be greater than. So it can be 8 or greater. I can't get that highlighted properly. There we go. In comparison compound operator is saying that it has to be at least 8. So it can be 8 or greater than 8. And as long as it's that, then it's a good password. If it's less than 8, then it's not a good password. Okay, now the comments that they have here, because I'm pretty sure you can probably see them. Like I said, I don't like them, but I'm not the one to judge on this. 0, again, is going to equal false. And for the first output we have on top where password length is either greater than or equal to 8, the result would be too short because it's only 5. And the second one, where it's going to end up being true, 1. And let's see here. Needs more characters. For 1, you don't typically see these options for passwords. You don't see it ever say it's too short. You don't ever see it say it needs more characters. It's an option. I mean, you can put it into the program that way if you want to. But the first output here is simply stating that it's going to be false. It's too short. Like I said, I don't like the way they have that worded there, but that's the way it is. It's false, it's too short, it's not good, not long enough. The second one being true needs more characters, so we're stating that yes, password length is less than 8, so put more characters in there for the password to work. And I'm trying to my best to on this one right here to uh, add the wording to make this statement from their comments and this statement from their comments work. But anyways, so yes, we got a simple comparison operator and then a compound comparison operator. Moving on. So that's comparison right there, comparing one variable to a value, or like with addition and stuff, you can have a value and a value, uh, a variable and a value, or a variable and a variable. And it doesn't necessarily always have to be integers you're using. We can come up with a bunch of different ways this will work. I think the idea that I had before with this, I don't actually think I made up anything with this yet. I think I was using theirs and manipulating theirs and stuff, their examples and stuff to try to make this work, but it is what it is. Think of this like, I mean, we're seeing age for voting, we're seeing password length for a password for an account. You can also think of it as, instead of age for voting, it could be age for getting into a certain place or for drinking. It could be height for riding a specific type of ride at an amusement park or at a fair. Um, it could be old enough to fly alone, which that's a whole different story right there and stuff. Like I said, I don't know how a lot of that works. I don't do a whole lot of that anymore. It could be whether or not if it's a hospital instance, are they on other medications or not? So, or are they allergic to certain medications? If you're talking about food, it could be, are they allergic to this kind of food or that kind of food? You can have a bunch of different variables in there for this. Let's go ahead and clear this out here real quick, just to show you an example. So, int, let's say that we want to determine if we have enough room in a certain room. Okay, so we got room, and this will hold, the capacity will be, in fact, we'll put that in there. Room cap is, let's say, 200 people. Okay, and with this program right here, we can go ahead and call people int person, and we can kind of just leave it open in this case because we don't know how many people are going to get in. But if we do end up reaching a limit and person ends up becoming, say, 175, and just put it 174 since I typed that in there, you start writing a program and stuff that increments and decrements and stuff. And then you also add in, is the capacity large enough to fit this group of 10 people into it? So you get up to 190 people in the room, and then you want a comparison operator to determine if 15 more people can fit. And then the next thing you know, the person that's letting people in, the person at the door, whatnot, they're looking at the tablet and adding more people and stuff. And well, they got 10 people here, so instead of hitting the add button 10 times and stuff on the program, they just input 10 and hit enter. And the next thing you know, it says too many at capacity. The room is currently at capacity at 200, so 10 people won't fit. So what if the person at the door wants to know how many people are left that can be fit in there? Well, you can also add to that program right there, telling them current capacity is at this, max capacity is at this. So, what else? I know that this sort of program right here with comparison and capacity and all that sort of stuff is definitely used on cars for a lot of different things. You got gas level to determine the fuel level. Is it full? Yes or no, and then you might have a light or an indication and stuff just simply saying that it is full. Even a word, uh, yeah, it appears on your dash or whatnot. Or if you have a low fuel level light, well, once it gets to a certain level and stuff, it's constantly asking, is it low or is it full still? One or the other. It doesn't care how much is in there. It just wants to know if it's low or if it's full, and it's constantly asking that question every second or whatnot. And as soon as it passes that mark, it indicates that that no longer is true, so it's switching the value from true to false, or from false to true, however you write the program in there. So I think that's enough on comparison. That kind of explains a lot of different programs that might be used for your car, for amusement rides, for getting into places, counting people, counting age, etc. Let's go ahead and move on to the next one. Next one is logic. Like I said, we showed this a little bit in the CPP reference guide. We just haven't talked about this one. And, or, and not. Logic operators. With logic, and I don't even think we had this in our list here, but you can go ahead and add it to your list if it's not on there. Logic operators. As with comparison operators, you can also test for true or false values with logic operators. Logic operators are used to determine the logic between variables or values. Okay, so we got a few different ones here. We got, type these out. We got and, which is the and operator. You got this, oops, that right there, which is the or operator. And then you got this right here, which is the not operator. A way kind of, it doesn't even, no, it doesn't even give examples on this one yet. It gives some tries and stuff. Well, it does kind of give examples over here, so we'll go ahead and type these into here. I don't think they're going to work too well, but we're going to go ahead and type them in there anyway, just so you can see them used. So int, actually, I'm not going to use that, x greater than 5, and x less than 10. So pretty much this is simply asking, is x larger than 5 and less than 10? Actually, is x less than, less than 5 and less than 10. So pretty much it's somewhere between, somewhere underneath being an integer. Well, we don't know if it's an integer or not, so basically anything under 5. And it can be 4.9999 repeating over and over. And yes, it would make this true, because on both sides it has to be. For this side, though, you can end up putting true right here. If this side is true, but then if this side is false, then this entire statement becomes false. And that reason that is because of this and. Both sides, this side has to be true and this side has to be true for this entire statement to be true. If one side is true, one side is false, that makes the entire thing false. Because of the and operator. Both sides have to be the same in order for the outcome to be true or false. So kind of a way I think this works and stuff is, and I'll type this out for you. So if it's true and true, and I will put that operator in there. There we go. And there we go. This statement right here then becomes true because both sides are true. Now, if this side is false, and this side is true, the entire statement at this time becomes false. Because with this AND operator, both sides, left side and right side, have to be the same in order for it to be true. Not necessarily the same way with false. Think of it this way. If it was something dangerous, okay, is the stove on and is your hand on the stove? If both of those are true, then yes, you're in danger of burning your hand. Is the stove on? True. Is your hand on the stove? False. So therefore, are you in danger of burning your hand? No. Is the stove on? No. Is your hand on the stove? Yes. Are you in danger of burning your hand? No. Is the stove on? No. Is your hand on the stove? No. Are you in danger of burning your hand? No. That's how that kind of works. I will actually go ahead and write that. I like that little bit there. So I'll finish writing this out true so you can see these examples this way. I like that example. That's a really nice example right there of how that works. Is false. False and false. And I actually typed that in there wrong, but that's fine. False. Let me fix this up here real quick. Okay. So the examples that we're going to use for this, and this kind of works with all of these, okay? The and is for both sides to be one way or the other. Both sides have to be true in order for it to be true. Otherwise, the entire thing is false. With or, one side can be true and the entire statement becomes true. So you only end up with one false. With not actually, so I'm going to go ahead and keep that up here for now. And I'm just going to move this down here a little bit. Yep, nope, I didn't want to do that. Open that back up. Come on, stop arguing with me. Here we go. So we're going to move that down a little bit. So with and, also known as and, we normally just use the symbols, not the word though. And like I said, we're going to use the whole stove analogy. Is the stove on? We're going to put a tab in there. Is your hand on the stove? And then tab, and then burn. Because that's the result, okay? Actually, no, we don't even need that. Yeah, we do need that, burn. That would be the result if it's both true. So, we are going to go ahead and add in this. Think of, like I said, this being and right here. So, is the stove on and is your hand on the stove? You're going to get burnt. Okay. So, in this case, we're going to say true. I'm going to tab forward, put the and operators in, tab forward a little farther, and say true again, and tab forward a little farther, and this is going to bring this outcome to true. You're going to get burnt. If this one is true, and this one is false, how can you get burnt if your hand is not on the stove? So this is going to be false. If this one is false, the stove's not even on, but yes, your hand is on the stove, then it's still going to be false. because you can't get burned if the stove is off, even though your hand's on it. Now, both of these are false. The stove is off, and your hand is off the stove, then obviously there's no risk at all. Simple. And that aligns just with this right here, and that's exactly how this works. Both sides have to be true in order for the entire thing to be true. And here's something that this doesn't mention, okay? You can end up having another and in here, another equation in here. X equals 10, and so forth and so on. You can keep going with that for as long as what you want to where you have more and more and more. Now it's showing X's on this right here and stuff because X is not identified, and it's showing right here because of the left and right values. Expression must be modified, so we don't have this written out right because we don't have X identified and all this other stuff. We're just kind of showing the use of it and how a logic operator works in an analogy. Now, if you replace this with or, this analogy will not work. Those are the ors. But if we're looking at this down here, the symbol for or is this. Ah, crap. Oh well. Oops. So as long as one side or the other is true, the statement's going to be true. Hold on a second. So again, we're using or in this instead. So if one side is true, then the entire thing is true. In fact, the compiler may not even look at the other side and stuff if one side is true and you're using or. If one side is true and you got the or statement, the compiler, I don't know for certain if it does or not, but it may not even look at the next one because it's going to obviously be true no matter what. No matter what the result of the second one is, it's going to be true. One side or the other has to be true just for this to be true. This analogy no longer works for this right here. Because in this case right here, where one side is true, like I was saying, and it sees this operator right here, it doesn't matter what this is, because now this has become true. Same thing with this. It sees false right here. It sees the operator. So this right here and stuff is a final decision right here. Are you true or false? It says true. Okay, so we are true then. The only way this is all the way false is if you have false and I'm using control. That's why I did that. We don't want that or that. Let me make sure it's the only thing we got up here. Whoops. Okay, sorry. There we go. Okay, false and false to get an actual false reading. So with or, everything has to be false in order for the entire thing to be false. With and, everything has to be true with the result to be true. Not, that one's a different one. And I'm not going to get into this because the examples don't even get into this very well. We will wait until we get to the better detailed explanation of not, because everything is opposite. So it's not even the operator that becomes opposite. It's the values that become opposite. It's like this, not true. Well, this is still kind of true and this is still kind of true, so that kind of makes that true, but this is not true. So this actually is false. And that's why I don't want to get too much into that right now and stuff, because we'll wait until we get to the more detailed stuff. Just realize that not does exist. and it makes statements a lot harder to read and stuff because instead of reading the way you know, now you're having to flip your hand over and stuff and reading without seeing them or backwards or whatever. It's just a huge confusing mess dealing with not. People do use it though in their programs. It is useful in your programs and stuff, but you really have to get used to it. It's kind of like driving a car backwards, going all the way down the road. You're used to driving it forward all the time. Now we're going backwards all the time without hitting anything, staying in our lane all the time, sort of thing. And the faster you go, the harder it is to steer. So, just, yeah, it's not as easy to deal with not, but it does exist. It does exist for a reason. It has its uses and stuff, but we're not going to get into that right now. We'll wait until we get to more details. We'll just get the basic stuff down. So that's, I mean, like I said, it doesn't have a whole lot of information on logic and stuff. It doesn't even explain all that right there in detail. It just kind of gives a few examples and therefore just kind of moves on after that, just to show you exists. All right, let's go ahead and go to the next exercise. Operator precedence. I don't remember this one. I really don't. So maybe this is something I'll relearn or refresh my mind on. Operator precedence. When a calculation contains more than one operator, C++ follows order of operation. That's what it is, just like in math. Rules to decide which part is calculated first. Okay, so we have a lot of operators in this. Okay, and each one of those operators has priority over another. Some of them have the same priority as the other. That is a huge list to go through and stuff. It is a lot like math, but it's not. Some of them work the same way as math does. Like when it comes to an expression that deals with multiplication and adding. The multiplication comes first, left, right, and then adding goes second. If you need two specific numbers multiplied or added together first before any of the rest of it get done, then you have to put parentheses around it. We got some examples here. Let's go ahead and do the examples. So, this is a huge list because you've already seen that there is a huge amount of operators in here. And this does specifically say operator. So there are some operators that have higher priority than others. There are ways to make other operators higher priority than others. So that is, yeah, if you know about operator order and which one comes first, which one comes second when doing math, then you already know that this has a huge category to it. Because not only does it deal with um, the math problems in this, it also deals with the assignment operators, the logic operators, which one comes first in those parts. Um, the comparison operators. If you, well, let's go ahead and get this example in here real quick. Int result 1 is 2 plus 3 plus 4. Oops. Nope, that's not plus, it's times. Gotta see this better. 4 done. There is a comment right here and stuff to kind of show you how this math is done, but that's fine. We'll get to that here in just a second. We're going to do the next one here. Result 2 is parentheses 2 plus 3 times 4 and there's another one right there. Now we're going to do some outputs right here. I'm not doing the comments just yet for a reason. Result 1, new line, result 2, new line, end. Okay. So we got our stuff together. In normal math, yes, we know multiplication comes first. So it would normally be 3 times 4 plus 2, which makes 14. 3 times 4 is 12, plus 2 is 14. Okay, and the second one, it has a parentheses around 2. Well, in normal math, we know that anything in parentheses comes first, so it'd be 2 plus 3, which is 5, times 4, which makes 20. So the first one would be 14, the second one would be 20. Does it work the same way in C++ as what it does in math? Well, according to the comments, it does. Comments being that it would be 2 plus 12 equals 14. And then the next one, the same way. Not the same way, actually, the parentheses comes first. So it would be 5, because of what's in parentheses, times 4 is 20. But we don't know how all the operators work together. We really don't. And there is a way to determine it. There is a chart that says which operators have higher priority over others. After that and stuff, it's just left to right. So if it's a bunch of addition signs and stuff, it's obviously left to right unless they're in parentheses, and then what's in parentheses goes first. There's another way to determine this. So first off, we are going to check and make sure our results are correct, and our program is going to work just the way it's determined on this lesson here. So we're going to go ahead and save it and run it. And yes, we get 14 and 20. What if we didn't know about these comments? If these comments weren't in there. Let's make up another one then. Let's go ahead and keep the results in the spot where they're at and make up our own. Okay, so 2 plus 10 times 8 parentheses, no, sorry, yeah, plus parentheses 3 plus 3 plus 3. We have no idea what this is going to come out to. There's no result. There's no example set for us or anything. We don't even know how this is going to come together exactly. We do need a space in there to show that. There we go. We do assume that the parentheses is going to come first. How would we determine that? Let's go ahead and save it and run it. What's our result? 91. How did we get 91 out of that? Let's see. If we do parentheses first like normal math, it'd be 3 plus 3 plus 3, which is 9. You're going to multiply 10. 10 times 8, which is 80. You're going to add 2 to 80, which is going to be 82. Then you're going to add another 9 to that, which is going to be 91. So that's exactly how they did it. They did parentheses first. So you can kind of reverse engineer the math if you remember how to do math properly and see if it's being done the same way this is. But what about we have this whole thing right here, modulus. I don't know if modulus is in math or not, the remainder. Remainder of 8 divided by 2, or 10 divided by 8. What's this going to be? 13 now. What is it doing first? Is it still doing does the parentheses still have priority over the modulus? Let's see, 9. If that's the case, 9. That's going to be 1. 10 divided by 8 is going to be 1 with a remainder of 2. So, and since this is modulo, this is going to be 2. Okay, so then we're going to do 2 plus 2, which is 4, plus 9, which is 13. There you go. That tells you right there. But you have to know how modular works. There is a chart somewhere. I'm not sure where. You probably simply open up a new site right here and see, type in operator, hold on, C++, operator precedence chart. There we go, right there. And let's see here. It's right there off of C++. There you go. There's the order. What has priority over others? So this right here, scope resolution, which we never have discussed about that yet, has highest priority, and then the increments have the next highest priority, all the way down to the comma. So uh, multiplication, division, and modulus have a higher priority than add and subtract, which has a higher priority than these. So there's your chart right there. It's on this. I just didn't know where to find it. So, but now we do. Operator precedence. Okay, let's get rid of this. Let's close that out and that out. Come back to this right here. And that's pretty much the end of this. We do have more right here. Why does this happen? Well, it's kind of telling us why it's happening. And 2 plus 3 times 4, the multiplication is done first, so the answer is 14. What if the addition happens first, you must use parentheses, which gives it 20. So it's kind of going through, and same thing with math. Always use parentheses if you want to make sure the calculation is done in the order you expect it. It will also make your code easier to read. Depends on how you want your code. Order of operands, here we go. So here's just a small list. We just found the big list. So parentheses comes first, then multiplication, division, modulus, then is addition, subtraction, and then comparison, equality, logic, and then assignment. Another examples right here and stuff, but we've already seen our big chart. After that, we go into the challenge, which we don't do challenges right now, so then we come into strings. At that point in time, that's where I'm going to go ahead and end the video right here, because that is a lot right there by itself, especially since we just discovered the whole idea of order of operation for mathematical or uh, arithmetic. So I will leave it right here for now, and I will come back and make another video later on, and we'll get started in strings. For now, though, I hope this was helpful. I am still learning more, even retaking this journey. So, I mean, was my journey through here and stuff. I understand a lot of this and stuff already, but going through this journey and stuff, I'm seeing a lot of things that I missed the first time. Plus, with my added sources up here of education, especially with this right here. I'm going to go and zoom this back out real quick. It's making it a whole lot easier to understand this stuff and find the information I'm looking for. It also is telling me how much this doesn't have in it compared to this right here, especially when you are referring to, let's see if we can actually find it out here real quick. I'm looking closely at the screen for it because I know these are kind of smaller words. With better eyes, I can see it better, but operation, yeah, it's right there. It's actually right next to the operator. So if we went back and stuff where we had the expressions and stuff where it says operators right next to it, what's in parentheses is precedence. Click on that and that gives you that whole list right there. So I am learning how to use the C++ reference and stuff, and this right here is giving me the ideas of being able to add all this into these example codes that I'm getting off of W3 schools and stuff to manipulate code, write better code, understand it better, all that sort of stuff. It's also sorting it out in my own head and stuff because I've got like a jumbled mess in my head right now of all this stuff, and going back through it and stuff is kind of allowing me to kind of separate things, organize things so it makes more sense to me. So even though I've done a journey through this once before and I'm showing you that journey right then and there, I'm also taking another journey currently and stuff, so you're seeing two journeys, the past and the present journey of me going through this. Interesting. All right, until next time, we'll pick up right here next time. So like I said, if you have any comments, questions, or anything like that you want to say, just leave them in the comments there. If I get to them, I get to them. It's not so much for me, it's to correct any mistakes that I make and stuff. Please feel free to do so. Hey, he said this at such and such time and stuff, and he's not right. It's actually this. I'm okay with that. So, again, till next time.